So today we look at the equation ax equals b a new way. So a can be viewed as a transformation or map from Rn to Rm. So let's look at an example of this. Let's look at A, which is 1, 0, 0, 0, 0, 2. And using our convention, m is going to be the number of rows, and n is going to be the number of columns. So n is 3 here, and m is 2. So let's consider ax for various x's. We'll do x is 1, 0, 0, 0, 1, 0, and 0, 0, 1. All right, so we'll look at this product. So a times 1, 0, 0. Remember, this is a definition of matrix vector multiplication. 1 is the weight on the first column, and then there's 0 weights on the other columns. So that's what that first product looks like. The second product is going to select the second column, and that's going to be the 0 vector. And then the last product selects the last column of A. So we'll get 0, 2. All right, and now we're going to view this as a map. So once again, we're going from Rn to Rm. So we have these input vectors, which are vectors in R3, n is 3. We have output vectors, which are vectors in Rm, which is 2. So let's draw a picture here. So we have R3. These are our inputs. And we have 3 vectors that we're inputting. I'll draw those vectors in a second. And then we have R2. These are our outputs. This is just like this. So we have x1, x2, x3. And then our outputs we'll call b1, b2. Those are just, it's a b vector and it has 2 coordinates. Okay, so our inputs are going to be 1, 0, 0, 0, 1, 0, and 0, 0, 1. Those are our inputs, our 3 vectors that are going in. And then our outputs, well, the 1, 0, 0 vector goes to 1, 0, so that goes to this vector. Our 0, 1, 0, this vector, let's draw some arrows here, so do arrows in red. So this vector goes to this vector. This vector goes to the 0 vector, which will represent by a dot. So this goes to the 0 vector. And then the last vector goes to 0, 2, which is a vector that has length 2. And it lies on the y-axis, or b2 axis exclusively. Okay, so we're viewing this, we've done these matrix vector multiplications before. We're viewing this as a transformation from one space to another. Put any vector in, you get a vector out. The input vectors are our 3 vectors and the output vectors are our 2 vectors. Okay, so from this perspective, solving ax equals b is equivalent to finding all the x that transform to b. And I'm going to use map and transform interchangeably. All right, so let's look at an example of this. Call this example 1.2. So what x maps to the vector 1, 2 with the transformation from above, which is A equals 1, 0, 0, 0, 0, 2. Okay, so now we're reversing it. Now I'm giving you a B, 1, 2. We're looking at this particular B here. And I'm asking what vector here mapped to this B? What vector in this space got me B here? So the way we do this is we set up the product. So we do AX equals B. So 1, 0, 0, 0, 0, 2 times x1, x2, x3 equals 1, 2. And this is a problem that we've solved before, type of problem that we've solved before. What we do is we take the A matrix, we augment it with the B vector, and then we RREF. And this is a very simple RREF. It's just going to be 1, 0, 0, 2, 0, 0, 1, 1, which tells me that x1 is going to be 1, x3 is going to be 1, and x2 is free. We'll call it t. And if we wrote this in parametric vector form, we get 1, t1. That's our x vector, which we can factor to be 1, 0, 1 and 0, 1, 0 times t. So the claim is that if I put a vector like this vector, and this is a whole line of vectors, then I'll output 1, 2. That's the claim. So we actually have a bunch of x's that all map to this single vector 1, 2. And just to make this a little more concrete, if t was 0, we get 1, 0, 1. If t was 1, we get 1, 1, 1. If t was 2, we get 1, 2, 1, etc. We get this is an infinite set. And the claim is that if we take any of these vectors and we transform them by A, we look at what they do when we multiply by A, we'll get out 1, 2. And let's just check this. So we'll do 1, 0, 0, 0, 0, 2 times, let's do our last vector here, 1, 2, 1. And if we do that, remember these are the weights on these columns, so this will be 1, 0 plus 2 times the 0 vector plus 1 times 0, 2, which is 1, 2. So any of these go in, and we get out the vector 1, 2, which is pretty cool. And if you wanted to visualize this with a picture, we have this set of vectors. So we have input vectors 1, 0, 1, so that's this vector. 1, 1, 1, that's this vector. 1, 2, 1, that's this vector. And there's a whole line of vectors that end here. All these vectors get mapped to this vector 1, 2, which is right here. So all these vectors, every one of these vectors in this line gets mapped to that single vector 1, 2.